early in the morning here in New Zealand as we prepare to launch our 76th rocket and latest mission from Launch Complex 1. Electron is vertical on the pad and launch preparations are proceeding smoothly as we come up to T-minus 14 minutes on the clock to liftoff. Thank you for joining us. My name is Murielle Baker, and I'm here at Rocket Lab Mission Control in Auckland, New Zealand for this morning's mission, a launch that we have called Follow My Speed for the confidential commercial customer that we have on board. Now, launch preparations began late last night to carry us through to this morning's launch, with Pad A now fully activated and propellant load almost complete, though liquid oxygen will continue to be topped off right up until about 2 minutes before launch when it goes into circulation. So far, though, we are tracking no issues with the vehicle and the weather is looking clear for today's T0, which is currently set for 1:17 a.m. local time or 12:17 UTC. And today's mission, as I said, is called Follow My Speed. It will be deploying a single satellite to low Earth orbit. And at our customer's request, we'll be ending today's broadcast shortly after kickstage separation. This mission, though, is an exciting moment for the Electron team because about 48 hours ago, we were on the pad with another one of our rockets at our second launch site on Wallops Island, Virginia, where we successfully launched our latest HASTE mission and 75th launch overall. And with that 17th launch of the year, we beat our previous annual launch record set in 2024. And now today's launch will take us even further with 18 launches in 1 year. And the turnaround we're pulling off today is a huge moment for the team. From a technology demo mission to a commercial orbital mission, all within 48 hours and from opposite sides of the world. It'll be exciting to watch. Now, keeping an eye on that clock, it is T-minus 12 minutes and 50 seconds counting to liftoff, and time for one of the mission's most important calls, the go, no-go poll for launch. In just a few moments, our launch director for today's mission, Julia Wembacher, will run down the line of launch operators and wait for a go from each station, meaning that each operator is ready to proceed with the final countdown. Now, that poll is scheduled to begin at T-minus 12 minutes, so just a few seconds away now. Let's bring up the audio channels from Mission Control to hear how Electron is tracking for today's mission.
To all operators, LD on mission court. We are proceeding now with the go-no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go-no-go sequence is complete. We are currently T-minus 11 minutes and 20 seconds in counting. We are go for terminal count auto sequence at T-minus 10 minutes. From this time, the 3-web procedure is in effect.
That is a clean set of goes across the board, and Mission Control has cleared us to proceed with today's launch. It is now 1:06 a.m. local time, and we are at just over 10 minutes to liftoff, targeting the top of today's launch window as well. As usual, though, if we do need to push that T0 back for any reason, we have a 2-hour window during which we can try again with another launch attempt. Now, while the countdown continues, we have a bit of time to take you through the Electron rocket on the pad. And our orbital rocket is a small launch class of vehicle that includes 2 stages, plus a kick stage, that can carry up to 300 kilograms of payload to orbit on a dedicated mission. Electron stands 18 meters tall, or around 59 feet, and has a diameter of just over 1 meter. At launch, the vehicle weighs around 13,000 kilograms once it's fully loaded with its kerosene and liquid oxygen propellants. And as it leaves the pad, Electron produces 50,400 pounds of thrust at liftoff from its 9 Rutherford engines, each of which are 3D printed rocket engines that are made at our engine production facility in Long Beach, California. The Rutherford engines are identical across the first and second stage, except for a larger expansion nozzle on the stage 2 engine that improves its performance in the vacuum conditions of space. Now, these engines are also the first of their kind to use an electric propulsion cycle powered by batteries. And these high voltage batteries, or HVBs, provide power to the LOX and kerosene pumps for the engine. And we often see them in action when we are in space during the second stage burn. At the top of Electron is its payload fairing, a split clamshell design made of carbon composite that opens and falls away when the vehicle is in flight. Now, during separation, each half rotates on a hinge away from the payload as the fairing opens up, exposing the customer satellite to space for the first time on the mission. Now, inside that fairing is Electron's kick stage that the payload is attached to. The kick stage is an in-space platform that uses its own propulsion system to deliver satellites to their orbital target. And at the heart of that propulsion system is the Curie engine, another 3D printed rocket engine that we developed for Electron that is supported by 6 cold gas reaction control system thrusters, or RCS, that helps to position the kick stage for payload deployment. Now, the kick stage platform itself is made from carbon composite material, just like the rest of Electron, right down to the linerless common bulkhead tanks inside the first stage and the vehicle's interstage. And using carbon composite helps to decrease the mass of Electron and improve its performance, but it's also the secret to Electron's success when it comes to rapid production for its high launch cadence. Now, without any propellant loaded, the rocket looks almost entirely black from the carbon composite. But where you're seeing the white stripes on the vehicle now is where the liquid oxygen inside its tanks is freezing moisture on the outside of the rocket. And if nothing else, it's an easy way to visually tell how far along into the propellant load process we are. Now, for today's mission, there's another piece of Rocket Lab technology that will play a key role in making this mission a success. Now, Follow My Speed's payload will be deployed using a separation system built by our team that is called the Advanced Light Band, or ALB. And this is the mechanism that separates the spacecraft from the launch vehicle once we reach orbit. It's non-pyrotechnic, which means it doesn't use explosives for separation. Instead, it uses a motorized release system to disengage its clamp-like band and send the satellite on its way. Now, here's more from the team about how they work and why they're important for precise orbital deployment on missions like these.
If we succeed in getting a payload to orbit, but it doesn't separate, all we've succeeded is putting a rocket into space.
There are no redundancies on a separation system. It has to work. Without that separation system, your satellite will never achieve its mission.
We want to make space more accessible, and we do that with integrity. So a satellite separation system, the easiest way to think about it is when a satellite is going to space, it has to stay connected to the rocket, and then when it gets where it's going, it has to disconnect.
A separation system is somewhat like the seatbelt on your car. You kind of forget about it until you actually need it. And so it has to be a reliable mechanism that's going to work.
It's easy enough to keep it connected, but being able to release instantaneously is where it requires a lot of work. And what we do so well here at Rocket Lab is we make sure that that will work. If you don't have a reliable separation system, your satellite can get damaged during launch or fail to separate, at which point this is a catastrophic failure for a mission.
Every engineer in the building here has a pretty high orientation for detail and quality. The idea that we won't ship anything that we're not 100% confident will work, that trickles down into our day-to-day, and that really helps creating something that is both beautiful but but 100% reliable.
So our separation systems, we have 3 of them. They're all field resettable. They're easy to integrate, and ours are electromechanical systems. They're not using any consumables, so it's a much gentler, much more benign separation event. There's a less likelihood of damage to any of the sensitive components that might be on our customer satellites.
With motors, you can operate them over and over and over again and be confident in their reliability. They'll tell you about the health of the mechanical system. So you know the mechanical system is going to work, you know it's going to deploy. You are truly testing and confirming the operation of the unit that's going to work in space.
It is hugely inspirational to me that Rocket Lab shares in our customers' mission success. It is a privilege and a responsibility that nobody at Rocket Lab takes lightly.
I have a lot of passion for this work, and every bit of it goes into creating a product that is successful.
We build beautiful things. We want to make the most efficient design possible. We want to make it as easy as possible for our customer. We want a product that shines in its function, that you know is going to work after the launch button is pressed.
Over 1,000 satellites delivered by our separation systems to space and counting, and we are looking forward to adding one more to that number for today's customer. It is otherwise T-minus 4 minutes on the clock, and coming up shortly, Electron will switch to internal power in preparation for launch. Now, by this point in the countdown, Electron is fully loaded with propellant and will soon switch to circulating liquid oxygen throughout its internal systems. And when that happens, we should hear a call out from Mission Control confirming that LOX loading is complete and Electron's tanks are topped off. Then, just inside a minute before liftoff, we can expect a call out that Electron's first and second stages are pressurized for launch. And then just a few seconds before T0, the Rutherford engines will ignite, and then when they are at full power, Electron will lift off the pad and head to space for its 76th launch. Now, the Follow My Speed payload remains healthy, and we are tracking no issues with the weather, the range, or the vehicle as we approach now T-minus 3 minutes into the count. All systems are currently go for an on-time liftoff at 1:17 a.m. local time from Launch Complex 1. And we are standing by now for confirmation that Electron has switched to internal power at right around the T-minus 2 minute mark to liftoff. So let's bring up the audio channels from Mission Control and listen in to those final moments before launch. Go Electron.
Let's go green.
To all operators, we are go for auto sequence start at T-minus 2 minutes. LDs go for launch. And we hit an abort. And to all operators, we are proceeding with the immediate auto sequence abort checks. GC LD emission code.
LDGC.
Please confirm the launch inhibit mode is enabled.
Negative.
VCON LD emission code.
LD VCON.
Please confirm the abort auto sequence executed nominally.
Confirmed.
Copy, thank you.
Is it Okay, you heard it there from Mission Control. Our launch director has called an abort in that countdown sequence. So we're going to keep those audio channels up for a little while yet just to hear how plans are proceeding and hopefully make another attempt.
Abort checks sequence 70. Copy and work.
Vehicles on external power.
PLS, LD and mission code.
LD PLS.
PLS, could you please inform me on the LOX top-up status for both stages?
Both stages are on target.
Copy. And top-up is still ongoing?
That's confirmed.
Copy.
LD stage on mission.
Stage LD.
Stage terminal abort checks are complete.
Copy, thank you.
LD avionics on mission.
Avionics LD.
Avionics terminal abort checks are complete.
Copy, thank you. And to all operators, LD and mission code, we are proceeding with the recycle sequence. Issues seem to be that my abort key had a temporary data dropout and triggered and caused an abort. But the sounds of it was just very unlucky, and we are preparing to recycle.
All right, you heard it there from Mission Control. Sounds like we are going to make an attempt at a recycle during this launch window. So we'll stand by for more information as it comes to hand, but let's keep an eye on that countdown clock to see it reset, hopefully very soon.
VCON LD and mission code.
LD VCON.
Could you please shift the auto sequence, Golf 2400.
Copy and work.
LD sub, LD mission code.
LD sub.
Could you please clear the required steps in the ICD?
Copy.
And to all operators, LD and mission code, please continue to monitor your critical systems and be prepared for a go-no-go poll. On restarting of the count, we're currently picking a new T0, and we will jump into the T-minus 12-minute count.
Okay, just reconfirming what we heard there from Mission Control and from the launch director with that latest update. It sounds like the team is resetting the countdown to just before T-minus 12 minutes to launch to run another go, no-go poll. And so we're standing by to have a new T0 liftoff time confirmed. In the meantime, stick with us for this recycle attempt that will be coming up shortly. All right, as you can see in the top left-hand corner of your screen there, the countdown clock has been reset to T-minus 16 minutes and counting, and that's in the lead up to a go, no-go poll that we have scheduled at T-minus 12 minutes. So stick with us, we're waiting to hear the latest from Mission Control in this launch attempt for Follow My Speed.
To all operators in the mission code, we have reset the count. Currently T-minus 14 minutes and 51 seconds in counting.
Okay, T minus 12 minutes, 27 seconds and counting, which means we are just moments away from the launch director running another go, no-go poll for tonight's launch attempt. So let's bring up the audio channels from Mission Control now and listen in to this recycle attempt.
And to all operators, LD on mission code, we are proceeding with another go, no-go sequence, starting off with stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Beacon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
The go, no-go sequence is complete. We're currently T minus 11 minutes and 25 seconds and counting. We are go for terminal count sequence at T minus 10 minutes. From this time, the three-word procedure is in effect.
Great news there from Mission Control. We have cleared through that go, no-go poll for tonight's launch attempt. So now at T minus 11 minutes and just a couple of seconds and counting until liftoff. We'll be back with you with further updates very soon.
GC earlier mission code.
LD GC.
Please proceed with sequence 58 paired terminal check.
Copy. Paired terminal checks and work. Stage 1 igniter pressures verified. High top pressures verified. LD GC mission.
GC LD.
Paired terminal checks complete.
Copy, thank you. Avionics LD on mission code.
LD avionics.
Please proceed with sequence 59 avionics terminal checks.
In work. S-band is switched to high power for flight.
Stage LD mission code.
LD stage.
Please proceed with sequence 60 stage terminal check.
Copy and work.
GC LD mission code.
LD GC.
Proceed with sequence 61 launch pad ready.
Copy. Launch pad ready and work.
Stage 1 and 2 high voltage batteries ready for flight.
All pump lips are nominal and all engines are ready. LD stage on mission.
Stage LD.
The stage terminal checks are complete.
Copy, thank you.
LD avionics on mission.
Avionics LD.
Sequence 59 is complete.
Copy, thank you.
All right, as the countdown continues for this launch attempt, the countdown is on as well for our new, much larger launch vehicle, Neutron, ahead of its debut in 2026. Now, Neutron will be launching from right next door to LC2 on Wallops Island, Virginia. And Launch Complex 3 for Neutron is our dedicated test, launch and landing site for our upcoming medium lift reusable rocket. Now, here's more about Launch Complex 3.
And Launch Complex 3, looks a little different than most other orbital launch pads of a vehicle this class. And we did that intentionally to reduce the amount of bespoke infrastructure that needs to be created to support this rocket. You'll see the pad is quite clean with its propellant farms supporting the main launch pad in itself. And that's really largely there to minimize the amount of infrastructure needed for rapid reuse.
Launch Complex 3 is a world-class medium-lift launch facility. It's constructed on pile-supported foundations. There's over 650 concrete reinforced piles that are between 70 and 80 feet in length. We have over 5,000 cubic yards of concrete on site for the foundations. In addition to that, we have approximately 700 tons of steel in the launch mount itself. We have a water tower that has a 200,000 gallon capacity and even more capacity in our cryogenic propellant storage on site. If you go out radially from the launch mount, you'll see a series of buildings that we call the launch equipment vaults. Those house all the electrical and controls equipment needed for both the ground systems and the launch vehicle itself. Towards the perimeter of the site, you'll notice large tanks. Those are the propellant farms that store and ultimately load Neutron with the fuel and oxidizer ahead of test and launch campaigns. There's quite a few block upgrades that are planned for Launch Complex 3. Most notably, you'll see block upgrades to the lifting and integration infrastructure out on the launch site itself. In addition to that, you'll see a doubling of propellant storage and a number of other assets put in place to support rapid turnaround times for both test opportunities as well as missions.
With Launch Complex 3 being the fourth launch pad we've built as a company, we've got a lot of experience in bringing infrastructure to life very, very quickly. We're also familiar with the Wallops Island and the NASA and the Virginia space teams, so that's enabled us to really hit the ground running in getting this pad built in record time.
Neutron is revolutionary in its design, revolutionary in its construction, and its operating model. This will bring a new capability and expanding the lift capability at the Mid-Atlantic Regional Spaceport. We have a marvelous relationship with Rocket Lab, and we're excited about beginning to launch the new Neutron rocket. Exciting times ahead as space continues to grow.
Rocket Lab with Neutron at Wallops represents an expansion of the launch capacity that's needed in the United States. You can't launch everything from the Cape, and the United States needs both Wallops and the Cape to be able to enable us to go to the moon and onto Mars.
The Rocket Lab team at LC3 is one of the best teams that I've ever worked with. It's a pretty driven group of individuals, and I'm super excited to see construction come to a completion and move into the test campaigns with the flight hardware.
Oh, I know everyone will be eagerly waiting for that launch to take place from LC3. I'll be front and center with all of you. But otherwise, back to today's launch attempt. We are now T-minus 3 minutes, 41 seconds and counting to our launch attempt, which means we'll be coming up to the auto sequence switchover in just a few moments, and a reminder for what happens when we hit the T-minus 2 minute mark. Electron will switch to internal power, and the onboard flight computers will run systems autonomously. So that includes making sure that the tanks are fully loaded with propellant, as well as circulating that liquid oxygen through its internal systems. And we should hear a couple of call-outs from mission control related to those events, as well as the call-out that Electron's first and second stages are pressurized for launch. And then we will get to ignition of those Rutherford engines just a couple of seconds before T0, and then lift off at the pad right on that T0 mark. So we're counting down now, T-minus 2 minutes, 50 seconds and counting. Let's go, Electron. I can't wait to see this one launch off the pad.
Go for launch.
Vehicle is fully on internal power. AFTS is green and enabled for flight.
LOX load complete, system is in recirculation. Anti-geyser ring is disabled.
Stage 1 and 2 tanks are pressed for flight.
High flow engine approach enabled.
We are T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3. Ignition. Liftoff.
Vehicles confirmed.
Beginning pitch over.
Stage 1 propulsion nominal.
There goes our 76th launch with a nice clean liftoff from Launch Complex 1 for Follow My Speed. And we can see a beautiful bright glow there from the 9 Rutherford engines as we make our way to space with Electron. And we are just above 5.5 kilometers in altitude and quickly climbing past 1,000 kilometers an hour. So that means soon our stage 1 engines will throttle down just a touch for max Q, or maximum aerodynamic pressure.
Approaching max Q. Cleared max Q.
HVB discharge nominal.
And that was the call out for max Q. So Electron is performing nominally during this first stage burn as the atmosphere thins and we continue to climb. The rocket's velocity is now approaching 2,800 kilometers an hour now, and we're coming up on several milestones in quick succession that will carry us through to the next phase of flight. So the first event is MECO, or main engine cutoff, quickly followed by stage separation and then engine ignition on Electron's second stage. Now, in order for Electron to carry out that separation cleanly, it has to throttle down its 9 Rutherford engines that are powering the first stage, and that is MECO. Very soon after that, separation takes place and the Rutherford engine on stage 2 lights up to propel the second stage onward to orbit and continue the mission. So let's listen in for these call-outs from Mission Control that these maneuvers have been completed.
15 seconds to staging.
Entered burnout attack mode.
MECO confirmed. Stage 2 ignition confirmed.
Stage separation confirmed.
love that sound of separation in that engine startup. That means that's a clean pass through MECO, stage separation, and second stage engine startup. And the mission is continuing nice and nominal for Follow My Speed. So soon we'll have fairing separation on the second stage, when the fairing halves will jettison and fall away now that they're no longer needed to protect the payload. Now, at our customer's request, we won't be showing that separation, but you might catch a glimpse of those fairing halves from the camera you see on your screen as they fall away. Otherwise, let's listen in for the call out.
Fairing jettison confirmed.
There we go. We heard the call, fairing separation confirmed by mission control. Now at T plus 3 minutes 47 seconds into flight for Follow My Speed as Electron cruises past 8,000 kilometers an hour. Now the next call outs we can expect to hear from mission control will be HV battery discharge nominal and approaching hot swap in roughly 30 seconds. Now those relate to the next actions for our battery packs that are connected to the second stage Rutherford engine. Hot swap refers to the action that switches in a battery pack with full power before the batteries that are currently in use are completely drained. Now once that hot swap occurs, the old packs are separated from the rocket and they fall away. And again, sometimes you can see them glint on camera as they go out of the frame of the camera view, but otherwise we listen out for confirmation from mission control that battery hot swap has occurred. So let's bring up those audio channels again now.
Stage 2 propulsion holding nominal.
T plus 5 minutes, 16 seconds now, and those tank levels are looking good as Electron's continuing well past 173 kilometers above Earth at a speed of, look at that, almost 12,000 kilometers an hour. So battery hot swap will be coming up shortly. Let's listen in for that one.
Guidance is nominal, 200 seconds remaining.
HVB discharge holding nominal, hot swap in 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
And there they go. That means hot swap was successful and Electron's second stage engine now is running on those new batteries. And the speed of the second stage continues to climb. We're past 16,000 kilometers an hour now and more than 190 kilometers above Earth. Now we have another 2 minutes or so to go until our next events on the second stage, which will be SECO and stage separation from the kick stage that carries the mission's payload. Still a couple more minutes of engine burn time to go though, and all systems are performing nominally with Electron continuing smoothly onto orbit. All right, T plus 7 minutes, 35 seconds, and counting into flight. Everything is proceeding nominally for this mission. And look, if you've just joined us, we had a great start to the launch, having successfully cleared the pad at Launch Complex 1 to make our way through max Q, main engine cutoff, and stage separation to reach this point now in the mission. So operators in mission control continue to monitor vehicle systems closely as we approach SECO. About a minute to go until then. Otherwise, Electron is approaching nearly 22,000 kilometers an hour, and we're getting close to that orbital insertion speed we need of about 28,000 kilometers an hour. So as I said, very soon we are going to see the vacuum variant of the Rutherford engine power down and shut off completely for our SECO maneuver, or the second engine cutoff on the second stage. Let's listen in for that call out that we have cleared SECO and achieved kick stage separation.
Guidance is in terminal, 20 seconds remaining.
SECO confirmed.
Nominal transfer orbit achieved.
Stage separation confirmed.
And there we have it. Rutherford has shut down and the second stage has separated from the kick stage, sending Follow My Speed's payload closer to its orbital target for payload deployment within the hour to complete the mission. So now that the kick stage has been separated to its nominal transfer orbit, it will follow an elliptical path around the Earth toward its exact destination for deployment. And this half orbit of Earth takes about 45 minutes. Now, once we're there, the Curie engine on the kick stage will ignite to circularize the trajectory. And then very shortly after that engine shuts off, we'll deploy our customer satellite to orbit using that advanced light band separation system that we talked about earlier. Now, congratulations to our customer and the team on the mission so far, but it is not over yet. As we mentioned earlier, at the request of the customer, we'll be ending the broadcast here. But with payload deployment coming up in the next 45 minutes or so, keep an eye on our social channels and website at rocketlabcorp.com for confirmation of mission success. Otherwise, thank you so much for tuning in to Rocket Lab's 76th launch. We can't wait to be back with you again soon. Until next time, this is Rocket Lab Mission Control, signing off.